I'm sharing my screen. Let me know if it is visible or not. Is it visible? My screen is visible to you all. Please respond.
Yes, ma'am.
No, ma'am.
Okay.
Yes, ma'am.
Just let's wait for some time. Hope now this is visible. My screen is visible.
Yes, ma'am.
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 Okay. Okay. What is the time? We should start. 9:17. Let's wait 2 minutes more. We'll start the class at 9:20. Your class starts at 9:15. Try to join by before the timing. Your class starts at 9:15. Try to join at 9:10. If you get the link. Okay. The time 9:18. Shall we wait for 2 minutes or shall we start? Students, shall I start or shall I wait for 2 more minutes? Priya is there? We should wait. Okay, let's wait for 2 minutes. All of you are able to see my screen, I guess, right? Yes or no? Please write in the chat box my screen is visible or not. Hope you are guys now. Now it's become easy for you to attend the class and read the class, give your attendance. This will become usual. At the starting phase, always it creates lot of problems. I hope all the issues has been resolved. 42 participants came. Okay. Okay, it's 9:20. I'll start with the class. Otherwise, we're lagging behind in the course. So, hope screen is visible to you all. Anyone can respond. Someone responds. Okay.
Ma'am.
Okay.
Visible.
Okay. Okay. So today's learning outcome is determine the maximum norm. My voice is echoing, right?
Yes, ma'am. Yes, ma'am.
Now it is okay.
Yes, ma'am.
Okay. So today's learning outcome will be determine the maximum.
Going voice. Going voice.
Hello? Hello?
Yes, ma'am.
Hello? Hello?
Ma'am.
Okay. So today's learning outcome will be to determine the maximum normal and shear stresses on inclined planes for the case of uniaxial load. My screen is visible and my cursor is moving. Are you able to see my cursor?
Yes, ma'am.
Okay.
Yes, ma'am.
So today we'll determine the maximum normal and shear stress. Earlier we determined the normal and shear stress on inclined planes. Okay, today we'll determine the what will be the maximum normal and shear stress for uniaxial loading. You are familiar with axial loading? Uni means only in one direction. So this is the geometrical figure. Suppose I have taken a section. Let me note. Okay, this is our geometrical figure. Okay, this is and a forces can be tension or compression. Okay, for uniaxial loading, the structural member is subject. It can be subject to a simple tension or compression. And today we are going to find the maximum normal and shear stress on inclined planes for uniaxial loading. This is a inclined plane. Remember, this is the transverse cut. In the first class, we have discussed the transverse cut and non-transverse cut. So, non-transverse cut can be taken as inclined plane. Please, students, let me know if my cursor and screen is not visible at any time. Okay, just interrupt me and let me know. So, this is the basically inclined plane, and this is the transverse area. And we are taking the uniaxial load. This is in tension always, and this always comes in compression. This will be in compression. Suppose you are compressing something, and this will be in tension. You are pulling it out. So we have applied a tension force P. This is only in one direction. That's why it is uniaxial. Okay. Now for this uniaxial load, we have normal shear force, and we will be this. Sorry, no, this is normal stress, and this will be shear stress. Sigma and tau we have discussed now. This will be your normal. What was the sigma? Sigma is equals to what? What was the formula for normal stress? Anyone? What was the formula for sigma?
Tension length by original length.
It was N by A, right? Normal force per unit area. We did a numerical also, right? So your sigma is your normal stress. N is your normal force. Per unit area will give you normal stress. In the same way, there was tau. Tau was shear force per unit area. So this is shear force, this is shear stress. Stress is always force by area. This is also stress, force by area. What force? Normal force per unit area. Shear force per unit area. Okay. Let me erase this part. Okay. So basically, we'll relate the first. We want to find the main aim of today's class is to find the maximum normal stress and shear stress on this inclined surface. To get that relation, first we should know what is the relation between transverse area and this non-transverse area. I have represented this non-transverse area as AT and area of this section, non-transverse section, as A, and I want to get the relation between A and AT. Okay, so by similar triangle, I'm assuming this is my one triangle where this A is your, this hypotenuse is represented by this area, this perpendicular is represented by AT, this This can be taken as perpendicular. This hypotenuse can be taken as this A. So I want to, let's relate this triangle with a similar triangle. Suppose I'm representing this hypotenuse as 1, this perpendicular as cos. Let me draw once far from this area. Suppose I'm relating this with another similar triangle. This is 1, this is cos theta, this is as sin theta. Okay. So from this two similar triangle, let's find out the relation. Suppose I'm putting A by AT, hypotenuse by perpendicular. So which is can be taken as equals to, what is the hypotenuse in this triangle? 1 divided by, this is our cos theta. Cos theta. So if I want to get a relation from this equation, I'll get a relation for A will be how much? It will be AT. This AT will comes to this part. So this AT by cos theta. This part is clear? How we got A equals to AT by cos theta? Response, okay? This part is clear or not? How we got A equal to, we got a relation, right? A equals to AT by cos theta. This part is clear? Hello?
No, ma'am.
No. Yes or no? Just type in the chat box. Yes or no? Just type in the chat box.
No, ma'am. No, ma'am.
Okay. Let me explain once again. Let me explain once. Our main aim is to find the normal and shear stress on this inclined plane. So what is normal stress? This is your sigma. What is shear stress? This is your tau. Okay, we want to find the maximum normal stress and maximum shear stress. So to find that, we should know the relation at first. Our aim is to know the relation. Hello? Please type in the chat box so that I can understand. The chat box so that I can understand. Ma'am, can you repeat once? Yes, I'll repeat. My screen is visible?
Ma'am.
Okay. Okay. So today's main aim is to find, earlier classes we know what is normal stress and shear stress. Now we want to find, suppose someone asks you what will be the maximum normal stress on an inclined plane and maximum shear stress in this plane. So you have to find the first relation, what is the relation of this stress with this areas, you have to find. Okay, means when you apply an external load, what will be the normal stress and shear stress on this plane, and what will be the maximum values. So to get the relation, first we are finding a relation between AT and A. Okay, understood what is our aim and what how we are started. Our aim is to find the maximum normal stress and shear stress on this inclined plane. Okay, so to find that, first we are starting with the relation between AT and A. Okay, so by geometry, see, this is we are taking a simple triangle. This hypotenuse can be represented by this area. By geometry, this transverse area can be represented by perpendicular AT. AT. Again, I'm taking a similar triangle. I'm assuming the hypotenuse is 1. Okay, and it's perpendicular. Suppose this is the theta, so this will always becomes your cos theta. Along the angle cos theta. This is your cos theta. This is your always the perpendicular along the. I hope this concept is clear. Whenever this is the theta, this part will always be your cos theta. Actually, I don't have graphic pad, that's why it is difficult to draw right here. I'm writing with my mouse. Let me try with more clear graphics. So again, I'm taking a similar triangle. Similar with this. I'm assuming the hypotenuse is 1. This is the angle theta. So this will be your cos theta. And this will be your sine. This is your one triangle. Again, this is your one triangle. This will be your A. This will be your AT. I'm assuming this one is
Screen is
1.
not clear.
Sorry?
Screen is not clear, ma'am.
Screen is not clear. What you able to see now in your screen?
Ma'am, your voice and the screen is not working the same plane side, ma'am.
Means it is not synchronizing, right?
Yes.
Okay, let me change my place. Let me change my just wait for some seconds. Actually, I have some network issues. I've shifted my place to my terrace. Now I don't know where to go. Just wait for some minutes. Do one thing. Till then I shift my place. All of you write your roll numbers in the chat box. Till I shift my place, all of you write your roll numbers in the chat box. All of you have written their roll numbers. Now again I'm sharing my screen. Let me know if it is visible or not. Now it is visible. Screen is visible.
Ma'am,
Okay. So this is our basically the geometry. We want to find the relation between A and AT. So I'm taking a triangle, two similar triangles. This is our one. This is one triangle, and this is one triangle. Here, this hypotenuse is represented by A. This perpendicular is represented by AT. I'm assuming this hypotenuse as 1. This is sine theta. And this one I'm taking as cos theta. So if I want to compare these two
See the
triangles,
triangles, ma'am.
still what?
No, ma'am, it's not coming at the same time.
Okay. I don't know what to do. I've shifted my place also. Means my screen and voice is not synchronizing at the same time, right?
Yes, ma'am.
Okay. So all of you tell me you have understood. Earlier you have understood or not that when I explained. Just let it be. Just see the figure. Okay. Just see the figure. If I say find out a relation between A and ET from two similar triangles, suppose you write in your own copy. Suppose my screen is not visible, write in your copy. Make two similar triangles. All of you make two similar triangles. Done? Always sit with pen and paper. Better you make a notes for every subject. That will be good. So all of you make two similar triangle. Done? So in one triangle, write a hypotenuse as A and perpendicular as AT. In the another triangle, write hypotenuse as 1, perpendicular side as cos theta, and base side as sin theta. Then, if I write A by AT, A by AT is equals to what? Corresponding to A, what is the thing in another similar triangle? It will be 1 divided by corresponding to AT, what will be the similar thing in the another triangle? It will be cos theta. Now tell me what will be the value of A? What will be the final value of A? Please mute yourself. Likha, mute yourself. Roll number 86, mute yourself. So what is the value of A? What value of A you got? Response. What value of A you got? Screen is visible. Cursor is moving now. Is it fine? Is it fine? Hello?
Yes, ma'am.
Okay. You are able to see my cursor and you got the A value. A value you should get 80 by cos theta. Everyone got? Do one thing, write yes. Whoever got, please write Y. I'm representing yes as y. Okay. So I'll move. Many of you have got. So I'll move to the next slide. So we got. So we got our A is equals to A. So we got A equals to 80 by cos theta. Okay. So from the last class, now we need to find the relation between sigma and n. We know our normal stress is equals to n by A. Okay. So we can write from this relation, we can write normal force equals to sigma into A. Okay. So let it be sigma like that. What is the value of A? 80 by cos theta. So put the value of A by 80 by cos theta. So what you got? What you get what you got the value of n? It's sigma 80 by cos theta. So our shear force is nothing but sigma 80 by cos theta. Hope this part is clear. In the similar way, what was your shear stress? Your shear stress was V by A, and we can write shear force as shear stress into area. And what is the A? We can write instead of A 80 by cos theta. So our V is equals to nothing but shear stress transverse area by cos theta. This part is clear. The relation of n with sigma and relation of V with sigma is clear. Hello? Hello? Is this part is clear to you all? Okay. Okay.
Yes, ma'am.
Okay. Then I'll move to the next part. Please don't write your roll number when I don't say, because I won't be able to see the chat box now. Those who have given the roll number, fine. I'll at the end of the session I'll ask again the roll number, and I'll take the screenshot of the chat box and your participant list. So don't worry about the attendance, but don't write now and make chat box very confusing. Okay, it's a request. Okay. So we have found, Guneshwar, mute yourself. So we have found the n and v value in terms of sigma and shear stress. Our shear force is sigma 80 by cos theta, and our shear force is tau 80 by cos theta. Okay, so we have here horizontal force, and here n is in normal direction, v is in shear direction. Okay, now we have to equate. Suppose this is a bar. Okay, this is your vertical force. This is the force coming from upward direction. This is the force you are getting from downward direction, and this is the force you are getting from horizontal direction. Again, this is the force you are getting from horizontal direction. If I say, suppose I'm telling this is F force, this is E force, this is A force, this is B force. If I say equilibrium the forces, what will you write? Equate these forces. What will be your equation? Tell me. If I say suppose summation of, if I say summation of vertical forces, take summation of vertical forces as 0. So what will you write? Reply fast. What will you write? I have given you a bar. I have applied a vertical force F in this direction. Again, I have applied a vertical force in this direction, which is E. And if I say for the equilibrium, summation of all vertical forces equals to 0. So what will you write here? Those who respond, they will get extra marks. I'm telling you, for the internal.
Plus all the sides.
Yes?
Plus all the sides is equal to 0.
What? F. You're saying F.
F plus
It will be plus or minus?
plus.
No. C. Good. At least you replied good. I have marked your roll number. So, see, F is in this direction, right? If E was in this direction, then it could be a plus. Now, the direction of both is different. So, if I am taking F as positive, I have to take E as negative. So, it will be F minus E equals to 0. If I take F as negative, suppose I am taking downward direction as positive, so and taking upward direction as, suppose I am taking downward direction as negative and upward direction as positive, then it will be minus F plus E equals to 0. Understand with this part, all of you? Clear this part?
Yes, ma'am.
Okay. In the similar way, if I say summation of horizontal force, take summation of horizontal force as 0. So it will be, what it will be? Suppose I am taking this direction as positive. So B minus A equals to 0. If the direction of A was like this, so it would have become B plus A equals to 0. Hope this part is clear. So I'll move to this part. I have given you this brief introduction so that you can get familiar with this direction. Okay. So this is our P is in horizontal direction, but in this phase we have force in normal direction and shear direction. So we have to resolve this P in this direction and this direction. Suppose this is making an angle theta. So this will be your P cos theta and this will be your P sin theta. Okay. Now I'm taking equilibrium I'm taking all perpendicular forces and on parallel forces. So if I take, forget about this part, okay? Suppose I'm taking summation of all perpendicular forces equals to 0. Now tell me what are the perpendicular forces are acting on this surface, on the whole structure. This will be one perpendicular force, yes or no? Right? This will be your perpendicular forces. So I'm taking this as N. Again, this is the perpendicular forces, but the direction is different. This is acting in this direction. I have taken this one as positive, so I'm taking this one as negative. So N minus P cos theta equals to 0. Clear with this equation? Summation of all perpendicular forces, I'm taking it is 0. In this surface, perpendicular force is N. The direction of perpendicular forces in this direction is this direction, so I've taken this value as minus P cos theta. Clear with this? Why I have resolved? See, this is the horizontal. I cannot take it. I have to compare with normal forces only. If this is normal, I have to take the normal part of this one. This is the horizontal. Here there is no horizontal force. Okay, that's why I've taken the result component part. Hope this part is clear. Yes or no? Please respond. Otherwise, I'll go ahead and you won't understand. Okay. So I can write N equals to P cos theta, right? And I know what is the N. N is your sigma 80 cos theta. So I can write N sigma 80 by cos theta equals to P cos theta. So what will be your sigma? Your sigma will be P cos square theta. This will be cos square theta by 80. So you got the relation between sigma and P. Your sigma is your P cos square theta by 80. Suppose you have been given, and sometimes you might have given a force and you have been asked to find the normal stress on inclined plane. So this will be the directly formula. What? Sigma is equal to P cos square theta by 80. This part is clear? Response. This part is clear or not? Sigma is equal to P cos theta.
Yes, ma'am.
Sigma is equal to P cos
Yes, ma'am.
theta. Okay, if this part is clear. Now come to the, we have resolved the perpendicular forces. Now we'll resolve the parallel forces. Okay. So I'm taking summation of all parallel forces equal to 0. Now this is one parallel forces to the surface. This is one parallel forces. Suppose here I am taking P sin theta as positive and this direction is negative. So P sin theta minus V equals to 0. You can take this direction also positive. Suppose I am just taking this direction as positive. So it will be V minus P sin theta equals to 0. You can take in this way also. Up to you. Okay. I have taken P sin theta. This direction is positive. So I have wrote P sin theta minus V equals to 0. Again P sin theta equals to V. This tau, and we know what is V. V is your tau 80 by cos theta. So I have put the value of tau 80 by cos theta. Okay. So your P sin theta is equals to tau 80 by cos theta. So you can write tau equals to, this P will be remain same. This cos theta will go to this side. So your sin theta cos theta by this 80 will comes down 80. This still here clear? Your tau is your P sin theta cos theta by 80. Now as per trigonometric, the value of sin theta into cos theta is your nothing but half sin 2 theta. Okay, your sin theta cos theta, if you go back to your previous trigonometric classes, it will be half sin 2 theta. So I have replaced the sin theta and cos theta by half sin 2 theta, and your formula becomes tau equals to P by twice 80 sin 2 theta. P by twice 80 sin 2 theta. This session will close in a minute. So I'll end this class. Okay. Hope everyone wrote their roll number in the chat box. I'll end this class, okay? Because this meeting will automatically, this class will automatically shift to the class. Hope everyone wrote their roll number. Anyone left to write their roll number?
When is the next class, ma'am?
I'll inform you. Wait. I'll take the next class from 10:10 most probably. Last roll number I've noted down. Pankaj Shah. Pankaj Shah, what is your roll number? Pankaj.
66, ma'am.
66. Yes. After that, so many wrote their roll number. Hope everyone wrote their roll number. Okay. And don't write 2 times. Just one is enough. Okay. Okay, students, I'm ending the meeting. Okay. I'll start with the same link. Join with the same link. Okay. At 10:10. I'm ending the meeting.